Okay, so if you guys look at in your book, problem number 43, this is what it looks like, okay? So number 43 in your book says, from section 1.6, says if you have a radiator that is filled with 3.6 liters, okay, of stuff. So 3.6 liters of stuff. And out of that stuff, 60% is antifreeze and 40% is water. Okay, what it wants to know is how much water should we drain out and then cap off and refill with just water so we reduce the amount to 50%. Does that make sense, you guys? If I start to drain this and then refill it with just water, that's going to lower the antifreeze level and increase that level. So I need to write an expression for it. It says antifreeze should be 50%. Well, the amount of antifreeze is equal, the antifreeze ratio is going to be the amount of antifreeze divided by the total amount of fluid in there. That should equal 1/2. Would you agree? All right. So we need to come up with how much antifreeze is in there at any given time. So how much antifreeze is currently in there right now before I even pull out the plug? 60% of what? 3.6. So 2.16 liters is currently in there. How much total is in there right now? Just all fluid. 3.6. Let's now pull the plug on the radiator, the drain plug, and let's start to let fluid out. Okay? How much fluid are we going to let out? We don't know. That's what we're trying to figure out. So we're going to let X out. All right? So is that subtracting fluid or is that adding fluid? That's subtracting. So I'm going to minus stuff. If I let X amount out, how much does that reduce the entire radiator by? It reduces it by X. It reduces the total amount by X. If I let fluid out, does that also reduce the amount of antifreeze in there? Does it reduce it by X? What does it reduce it by? If I let X out, how much of X is antifreeze? 60%. So it reduces it by 0.6X. Yeah, but I'm writing an expression for the amount of antifreeze over the total amount of stuff in there. Now, let's cap it off. Capped off, what are we going to do? We're going to refill it. What are you going to refill it with? Water. If I refill it with water, does that change the amount of antifreeze? No. Does that change the total amount? Yeah. How much water do I have to add in there? How much stuff did I drain out? How much stuff did I drain out of here, you guys said? X. So what do I have to put back in? I have to put X back in. So that changes the total amount, but it does not change the antifreeze amount. So as you notice, I have my expression on the top, 2.16 minus 0.6x divided by 3.6. X's cancel is equal to your ratio, which is 1/2. Now we can cross multiply and solve. Okay, so if we cross multiply and solve this, you guys, 3.6 times 1 is 3.6 is equal to 2 times 2.16 is 4.32 minus 0.6 times 2 is 1.2x. Subtract the 4.32 over. Yep. Negative 0.72 is equal to negative 1.2x. Divided by negative 1.2. 0.6 is equal to x. So that's the amount of fluid that we let out of it. But you got to understand really the beginning part. And you know what? There's actually an easier way to set that problem up. But I want you to see this so you can set other problems up. So I'm just thinking through the process, right? I've got this much antifreeze right now. I've got this much total. I'm losing 0.6 antifreeze. I'm losing X total. And then I'm replenishing the total, but I'm not replenishing antifreeze. Does that make sense? Okay. The answer, final answer for that problem is 0.6. And that's number 43 in your book. But, you know, that's a good example that could help model number 7.